Alright, hello everyone. We are going to do a simple problem from 2.2 in our book. Section 2.2 is all about limits. Alright, so we're going to be exploring the limits of this function. So this is the function f of x, whatever it is. This is what the graph of it looks like. Okay, and notice that there are some points where there's a break in the graph or a discontinuity. We are looking at the limit of this function as x approaches 1 from the left. That minus sign means we're approaching from the left. So you have to imagine a floating point. Here is 1. And we're getting closer and closer and closer and closer from this hand side. What is it getting closer and closer to? It looks like it's getting closer and closer to 2. Okay? So it's as simple as that. When we get here, now we're approaching 1 from the right hand side. We're getting closer and closer and closer and closer to our x value being 1. And it looks to me like we're getting closer and closer to 3. So we'd say that this equals 3. I didn't give myself quite enough room there. All right? So then we get to the all-important question, what happens if we write the limit of the function f of x as x approaches 1? We're not specifying whether it's from the right-hand or the left-hand side. In order for this limit to exist, these two numbers must agree, and they do not. So we get to say the all-important, the limit does not exist. All right? Because it needs to be the same number. Does not exist. All right? Then we've got the limit as x approaches 5. Well, now they're not specifying from the right or from the left, so it should not make a difference. So I can approach this point here, this is 5, from the left, and I get my value, which I believe is 4. And then when I approach it from the right-hand side, from the plus, this is the minus, this is the plus side, of course, it's the same value. We're over at 4. So this one, the limit does exist, and it's 4, even though the actual value of the function, when I plug that in, does not exist. If there had been some point, like at 2, I might say that this is equal to 2, but it isn't there, so I just say this does not exist. All right? So look at the graphs in the next two problems, 4 and 5, and see if you can fill in the numbers when it's approaching a number, and make sure that if you have a place where there's like a removable discontinuity or a break, the numbers have to agree in order for the limit to exist, like they agree right here. All right? Good luck.